So entry 2-1, graphing in vertex form. There's actually three total ways, three different forms that we can have, and we'll do one at a time. And they have different trade-offs. Like there's certain problems that lend themselves to one of the three models, and there's some that are easier to graph and some that take more work. So they all have trade-offs. So we need to be able to work with all three. So the first one, there are three forms. So graphing in vertex form. And so what I want you to write first is this that you really need to memorize, and you saw it yesterday. It's y equals ax minus h squared plus k. So that is the general form. So if it's in this form, the information we have, one of the most important points is what's one of the most important points on a parabola? The vertex. That is because that is the highest or lowest or maximum or minimum. So the vertex, when you're looking at an equation in this form, you can actually, that's the beauty of this form, is you can look at it and tell the vertex right away with no work at all. The vertex is at hk. And that's dealing with the shifting right and left and up and down. So the vertex is always at hk. Then A, just by looking at A tells you how wide or narrow it is compared to y equals x squared. So A tells how wide or narrow. So it's wide if the absolute value of A, let's just not even worry about the sign. This is a use for absolute value. If the absolute value of A is like less than 1, so like what are some numbers less than 1? 1/2 or 1/3 or 1/4. Then it's going to be actually wider because you're making the output smaller and it flattens it out. And if the absolute value of A is greater than 1, like 3 or 5, it actually makes it skinnier or narrower. So those are the two that you can tell by looking at A. And then also, what else does A tell you? If it's positive, it opens. Yep. So opens up. If it's really useful to know which direction it opens when you're trying to graph it. And if it opens up, that vertex will tell you the minimum, and if it opens down, it'll be a maximum. So in other words, if it opens up, then when we do applications, this vertex is a minimum point. See how it's the lowest point on the graph? Whereas if it opens down like that, then the vertex is a maximum. It's the highest point. So that's hugely important with our applications that we'll be doing later. So that opens up or down. And then the last thing is that the vertical line that goes down the center is called the axis of symmetry. Axis of symmetry. And that is a nice line because it gives you 2 for 1. Whenever you find a point on one side, you can reflect it over the other. Axis of symmetry, that will abbreviate AOS, as you'll see it, axis of symmetry. You can write AOS. And the equation, once you know the vertex, the axis of symmetry, so let me draw a little picture here and label these. So let's just say it opens up. This is the axis of symmetry, is this dotted line. What's the equation of any vertical line? Think about linear equations. Is it y? What is it? Is it y equals a constant or x equals a constant? X. Yeah, x is always the same, right? On a vertical line, the x coordinate. So the axis of symmetry is x equals, and instead of any, it's not just any constant, it goes through the vertex. So here's the vertex, right, at hk. So the axis of symmetry is x equals h. That is your equation. So once you know the vertex, you can say the axis of symmetry really easily. It's x equals h. So we're gonna add one more thing in your notes for this before we practice, is an example using all this information. So the example is, I'm going to give you the equation. We're going to pull out all the information and graph it. So here's the example. Is y equals negative 1/2 x plus 1 squared plus 5. So this is what we would do with that. First, so let's pull out all the information, then we can graph it. What's the vertex? Yeah, negative 1, 5. Get used to the fact that h is going to be the opposite of what you think, because why? Because look at the equation. It doesn't say x plus h. It says x minus h. Minus means opposite. So whatever number you see here, it's the opposite. So get used to that. It shifts it left 1 and up 5. The vertex is to the left 1 and up 5. Does it open up or down? Okay, opens down. And is it wider or narrower? It's wide, because the absolute value is less than 1, so it's wider. The axis of symmetry, the equation is, it's always x equals something. The x-coordinate of the vertex is the axis of symmetry. The equation, x equals negative 1. It's a vertical line that goes through negative 1. You'll see it in a second. And so now we're going to start to graph this. So since we know, picture where negative 1, 5 is, so we can kind of scale our axes a little bit. We're going to sketch it. So make your xy axis. So negative 1, 5. We're going to 1, 2, 3, 4, 5. We're going to just assume we're going by ones, even though on a test or something you should say that. So negative 1, 5. So we go to the left 1, up 5. There's our vertex. How many points do we need to graph a parabola? Just one? Just two? Yeah, we need 3 minimum. Yeah. So we have 1 so far, the vertex. We have this vertical line that goes through the axis of symmetry. Everything is symmetric, so I'm going to put that in there. So all I really need is 1 more point, and then I get the other one for free. So what would the easiest point be, so I don't have to do a whole xy table? What it would be? Beautiful, the y-intercept, exactly. So the other point that's easiest to find is the y-intercept. Use the y-intercept. You know why it's easy? Because you just plug in what? You just plug in x equals 0, right? Because along the y, this is the y-axis, I'll label it y, x. Along the y-axis, the x-coordinate is always 0. So you just take the 0 and you plug it right in there, and then the x goes away, and you could practically do this in your head. 0, we'll do it in our head and then we'll write it out. 0 plus 1 is? 1 squared is? Times negative 1/2? Negative 1/2 plus 5? 4 1/2. Yep. So we go 0, we go 4 1/2. 1, 2, 3, 4 1/2. See how it's wide? It even looks wide. And then we plot that same point on the other side. So here's the axis of symmetry. We go 1 to the other side, and that's our graph. We don't have to do any more xy tables. And it opens wider than the parent graph of y equals x squared. And now I'm going to write out plugging it in just so you have it in your notes, and then we'll be done with this part. So y equals negative 1/2 times 0 plus 1 squared plus 5. This is why we practice order of operations in evaluating functions. So first you do what's in parentheses and square it, and that gives you 1. And negative 1/2 plus 5 is 4 1/2. Or you could say 4.5 if that makes it, it's easier to graph in decimal. So 4 1/2 is right there. And there's our graph. So we are good with that. And